All right, y'all. So 9.2 support. And y'all, it's like 6 problems or so just to get you familiar with equation solving. So the first 2 examples, what we're going to do on the first 2 examples, we're going to be solving equations where we have a fraction equal to a fraction. Okay, so what I'm talking about, we're going to have something like this. A over B equals C over D. I got a fraction equal to a fraction. The way we solve this, the quickest way, is to do what we call cross multiply. Okay, to cross multiply, the top of the first fraction multiplies by the bottom of the second fraction. So you'll have A times D. That'll equal the bottom of the first fraction times the top of the second fraction, and that'll be B times C. So look, you're multiplying, and it makes sort of like a cross there, okay? And then at this point, you'll solve for whichever variable you needed to. But to clear the fractions, we're going to cross multiply when we got a fraction equal to a fraction. So these first 2 examples, that's what you're doing. So y'all, the first one says solve. They got 6 over x plus 1 equals 5 over x minus 3. So notice, I got the setup we got right here. I got the first fraction. 6 is A. X plus 1 would be the B. Second fraction, 5 would be the C. X minus 3 would be the D. So to clear our fractions, we're going to cross multiply this. Now, here's the thing you got to watch out for. You got a 6 up here. It's going to multiply by this bottom. But y'all, we got to multiply that 6 times both of those parts on that bottom. So this will be like a 6 times minus 3. So that'll be one side of my equation. That's my A times D. Then both of these, the x plus 1, both of them has to multiply times that 5. So this side will be 5 times x plus 1. So I'm just putting my 5 first instead of at the back. All right, but notice the fraction's gone after we cross multiplied. So now to solve this, we're going to distribute our 6 through the first parentheses. So see, that'll be 6 times x, which is 6x. And then the 6 times negative 3 gives me a negative 18. All right, y'all, then we do that to the right side. 5 times x is 5x. 5 times 1 is a positive 5. All right, so we cross multiplied, distributed. At this point, we're going to solve for x. Now, what I look at, I need the x's on one side and the numbers on the other. So since you got a bigger x here, I'm going to subtract 5x from both sides to move my x's. Okay, so 6 minus 5 leaves me 1x minus my 18. Over here, the 5x is canceling. All that's left is a 5. Now, you could have moved the x's over here and the numbers here, but you would have had a negative. When you add negative 6 to 5, that would have made your x negative. And I try to sort of keep mine positive. So now we got a 1x, but we need this x over here by itself. So that negative 18, to move it, we're going to add 18. Hang on, look at that. Here comes my x. 18's canceled on the left side. 5 plus 18 gives me 23.
Mm-hmm.
So if you wanted to check this, if you put the 23 here, that gives you 24. So you have 6 over 24 on the left side. 23 here minus 3 is 20. So 5 over 20 is 1/4.
Mm-hmm.
6 over 24 is 1/4.
Mm-hmm.
So that thing does check out, okay? Oh, y'all, so let's see what they did over here. This one, they got it x plus 5 over x is going to equal a 4 over 3. So y'all, fraction equal to a fraction again. So both of these, the x plus 5 both, are going to multiply by that 3. So that'll give me 3 times the x plus 5. Right side, this x times 4 is just a 4x. So first, we'll get rid of the parentheses by distributing again. So that's going to give me a 3x plus 3 times 5 is 15 equal to the 4x. Now, y'all look at this. You got a variable and a number on the left side. You only got a variable on the right side. So this problem, instead of me moving my x's to the left side, this problem will pretty much be done if we move these x's to the right side. Then we'll have our x's here, our number here, and pretty much be done. So let's move the minus 3x. Now, what would have happened if you'd have moved the 4x's to this side? Then you would have had to move the 15 to the other side, which would have been more steps. But y'all look here, these x's cancel. You got your 15. And then look here, 4 minus 3 leaves me 1x. Okay. So if you put the 15 in here, you get 20 over 15. 20 over 15 reduces to a 4/3.
Correct.
So y'all are not too bad. Just remember, fraction equal to a fraction, cross multiply it, and be done with it. So now we're going to look at solving equations with radicals. And your radicals are like square roots, okay? Now, here's the thing you got to remember about a square root. When you're dealing with a square root and it does not have a number in that notch, that number automatically is a 2. So no number is a 2. Any other number, they will put there physically. Like a cube root, they'll put a 3, and so on, okay? So, radicals. So here's the thing about radicals that helps us solve these. We got this little property, and it says, hey, if two sides are equal, so if I got two sides that are equal, then I can raise both sides to the same exponent and they'll still be equal, okay? And all that means is it goes back to the saying, what you do to one side of an equation, you got to do to the other side of the equation, okay? So the steps to solving radicals. Equations. So y'all, the very first thing you want to do is get the radical term by itself on one side or the other.
Hmm.
Now, usually we'll do this by adding or subtracting something to move it, okay? So get it on one side or the other. Because now that I got this radical on one side or the other, to get rid of the radical, we're going to raise both sides to the exponent that matches the radical. So what that means, the reason we're doing this right here, because we got a property that says if I got some root of a number and I raise it to the exponent that matches that index of that radical, if this exponent matches this radical, they basically cancel each other out and it equals the A. So exponents cancel radicals, radicals cancel exponents, okay? So y'all, once we raise both sides to the exponent that matches the radical will be gone. And at that point, we solve for the variable. And then any equation, if you want to, check needed. Check answer if needed. And that's a good thing about equations. We can plug our answers back in and see if we get what we're supposed to, okay? So these next few problems in support are going to deal with these radical equations to bring back those memories, okay? So these will just say solve. So we're going to solve a square root 8x minus 9 equals 1. Now, here's the thing. This 8x minus 9, it's all up under that radical, okay? So this is a single radical term here. You cannot move this 9 while it's under that radical. Okay, so we cannot add 9 to both sides. Like I said, so that means our first move, we got to get rid of the radical. And to get rid of that radical, remember, this is like a square root. There's not a number shown there. So it's like that number is a 2. So what we would do here, we would square both sides. And by that, I mean raise both sides to the second power. So square that side means I got to square the right side. So that's what that little property was talking about. If I square this one, I got to square that. Well, what's nice, when I square this left side, this radical cancels with that exponent. All that's left is the 8x minus 9. Now, the right side, you got to actually square it. And guess what? 1 times 1 is still a 1. All right. The radical's gone. So guess what? Solve for x. And we got 2 moves on here. First of all, we would like to move this negative 9 to the other side. So we're going to move it by adding 9. All right, so that 8x comes down. My 9's cancel. And y'all, what we got here? 1 plus 9 is a 10.
Yeah.
Hey, y'all, last step. Divide both sides by the 8. So that'll give me 8x divided by 8 will equal R10 divided by 8. So these 8's cancel, making that a 1x. I can't divide that, but we do need to reduce this fraction.
5/4.
So 5/4. Good job. So reduced our fraction. And then y'all, once we reduce fraction, we're done. Now to reduce this, we just divided them both by 2. Since both numbers divided by 2, and that's how I got a 5 and a 4, okay? So these equations are not bad. The main thing you got to remember is just try to get rid of that radical, okay? Now, let me change it up just a little bit on this one. We're going to solve a square root of 5x plus 2 equals 15. Now, y'all, here's the difference on this one. Over here, everything was under the radical. But notice over here, this plus 2 is not under that radical with that 5x. So that means on this problem, our first step is to try to get this square root of 5x by itself on the left side. So we need to move the 2. So come in and subtract 2 from both sides. That'll give us our square root of 5x. Those 2's cancel. And then what do we got? 15 minus 2 gives us 13. So now we're like this. This radical is by itself. We squared it. This radical is now by itself. So we're going to square both sides. So that'll give me a square root of 5x squared is going to equal 13 squared. So y'all, the left side ain't bad because this radical cancels with that exponent, leaving the 5x. Well, okay, so 13 squared would be 13 times 13.
169.
169. There you go. All right, y'all, done my last step. Come in and divide by that 5. So that cancels, giving me my 1x. Y'all, let's see. 5's a prime number, and I know what 5 don't go into 169, so that does not reduce. So we get a 169 over 5. All right, so like I said, the trick on it, get the radical by itself, square it, and then that radical's gone, okay? So let's see what we think we're going to do here. This one says solve. It's got a cube root of an x equals -3. So look here, this radical is by itself. But y'all, I'm not going to square both sides on this one. I got a 3 in that radical. So we're going to come in and do what we call cube both sides. So we're going to raise them both to the 3rd power to get rid of this radical. And then I always put my negative numbers in parentheses. All right, so look here. That radical cancels that exponent, leaving an x. All right, y'all, let's see. We got -3 times -3 times -3.
-27.
There you go. And then we're done. And that makes sense if you put a -27 in. The cube root of -27 is -3, right?
Yeah.
All right, so the last one for support, and then we'll get into actual college algebra lessons. This is a cube root x plus 5 equals 6. Now, the plus 5 is under the radical, just like this 8x minus 9 was all under that radical. So this radical term is by itself, which means I'm going to go straight into cubing both sides. So my cube root x plus 5 raised to the third power will equal my 6 raised to the third power. So I love these because this side is gone. The radical's gone with the exponent, leaves me at x plus 5. All right, y'all, here you go. Good one. 6 times 6 times 6. Oh, that's what 36 times 6.
216.
216. There you go. All right, one more step. Because I got x plus 5. We need that to be an x. So come in and subtract 5. Now you notice, once these equations are brought out, it's just a matter of solving these things, okay? So them 5s cancel. I got my x. And y'all
Equals 211.
211. There you go. So 211 goes in here. 211 plus 5 is 216. And we know the cube root of 216 is going to be that 6 there, okay? So, y'all, that was just the support part of this. And like I said, it was just to get you good at solving those fractional equations and solving the radical equations. So now we'll actually get into the college algebra 9.2. All right, let me get my camera back. So 9.2 for college algebra deals with what we call inverse functions. But y'all, before we get into the actual inverse functions, we're going to play with what we call relations. Okay? So we'll find the inverse of a relation, and then later on we'll step it up into the functions, okay? Now this is pretty straightforward on finding the inverse of a relation. So to find the inverse of a relation, we simply switch the x and y values. Okay? So all I'm going to do is switch the x and y values to find the inverse of these relations. So let's start with their first example. Find the inverse of the relation. Now, this relation they're giving me as a set of ordered pairs. They're giving me -9, 2. The next ordered pair is 6, -6. The next ordered pair is -5, 9. And then finally, the last ordered pair is 5, -5. So to give me this relationship, now on the answer, they're going to give you the curvy parentheses, but you got to put all the parentheses and all these commas in your answer when you find me the inverse relation. So y'all, what's the inverse of the -9, 2 point? And look what I said right here. To find it,
2, -19.
2, -9. All right, your next point.
-6, 6.
There you go. Because remember, these are all in the form of an X and a Y, remember, since they're ordered pairs. And all you are doing is flipping them. Okay, keep me going. And y'all in math, make sure you put these commas in between them, okay? So
9, -5.
and then finally,
-5, 5.
Yep.
all right, so if they give you ordered pairs, flip them, be done. Now the next one, doing the same thing pretty much, but now they're giving us an equation. And this one says, find an equation of the inverse relation. All righty, y'all. So the equation they're giving us is x to the third y equals -3. For my answer, now remember, all I'm going to do to find the inverse of an equation in this form, all we're going to do is switch the x and the y. But y'all, the exponent don't move. It stays there. So instead of this being an x to the third, I'm going to switch them. That'll
Y
be
to the third.
uh-huh. And then our x, and then that'll equal the -3. So here I switched them. Here I basically switched them. All right, so now we're going to look at what we call one-to-one. Because if a function is going to have an inverse function that I'm about to show you how to do in a little bit, it has to be what we call one-to-one. So in graphing, 1-to-1 means, now you remember when we did a function? When we did a function, we said, hey, in order to be a function, all the x values could only have one y value, right?
Yes.
And we did what we called a vertical line test to prove that. Well, y'all, one-to-one is almost the opposite. One-to-one means that the y values can only have one x value. Okay, so it's a function because the x's only have one y. Now it's one-to-one because it goes both ways, and the y values can only have one x. So what we do to check for one-to-one, we use the horizontal line test. Okay, now this horizontal line test says if a function is one-to-one, then a horizontal line cannot intersect the graph more than one time. Well, y'all, that's the same thing it was for the functions. On the functions, the vertical line couldn't intersect it more than once. 1-to-1, horizontal lines cannot intersect it more than once. So we'll look at a few examples doing that. And these will say using the horizontal line test. Determine whether the function is 1, 2, 1. So let me draw this first one. So here's my X and my Y axis. And let's see, this one sort of starts and it just sort of goes uphill slowly left to right. So I would run my horizontal line. Only intersects it once. Only intersects it once. Only intersects it once. No matter where I put my horizontal line, it only intersects my graph once. So this is yes, 1-to-1. So what would be a no? So we've been playing with parabolas. So y'all, is this upside down parabola 1-to-1?
No.
All right, yeah, I'm behind on my chat. Let me see what chat says. So the first one was yes, 1-to-1, but this one not, because y'all watch this. If I run my horizontal line, it intersects it on this side and that side. So that means this one is no,
No.
not 1-to-1. Now, I'm not going to lie. Let me say this. They can restrict the domain to make this 1-for-1. What if they said on this graph, we're only looking at it for the X values greater than 0? Well, X values greater than 0 are going to start at the Y-axis and go. Now, if they took out the negative X's, this part here is 1-to-1. But in order to do that, they got to restrict your domain, okay? This one, we got a full graph. It's definitely not 1-to-1. All righty, so let's get into the big thing for today. And that is going to be finding the inverse of a function. Now remember, f of x was function notation. So inverse function notation will be f -1 of x. This is what we call inverse function notation. So I'll start out with a function, and then when I find the inverse, I'll use this notation because it's the inverse of the function we started with, okay? So Here's going to be your steps to finding that inverse. The first thing we do, we're going to replace the f of x with a y. Because remember, f of x and y are the same thing. This is just function notation, and this is pretty much the variable notation of it, okay? So we're going to replace that f of x with that y. And then, y'all, what was the main thing I did earlier when I was finding those inverses of the relationships? Now, remember what we did when we found the inverses? We took the x and y's and switched
Flip 'em.
them. There you go. We're going to do the same thing here. We're going to switch the x and y variables. So pretty much the same thing. We're going to switch those x's and y's. Once I've switched the x and y's, I'm then going to solve for the new y variable. And this y used to be the x, remember, okay? All right, so you're going to solve it. You're going to have y equals whatever. So the last step is to replace that y with your f inverse notation. So I'm going to replace that y with f -1 of x. Now, I'm not going to lie. MathLab will give you this part, and they'll put equals, and you're just going to put the actual inverse function in, okay? MathLab will put this part for you.
Okay.
Now, remember, technically, to have an inverse, a function must be 1-to-1. Now, I'll save you a little bit of time on this. On these last 6 problems or so in the homework, where this kind of stuff starts at, every single one of y'all's will be 1-to-1, okay? Every single problem is 1-to-1. So you're going to have to find all the inverses for them. So here we go, y'all. These will say, for the following function, part A says, determine if it is 1-to-1. And then part B, now, better put yes on this A part, okay? Every one of y'all's will be yes for the 1-to-1 part. So then B says, if 1-to-1, find its inverse. Okay, so these last 6 are going to follow these instructions. I think that's how many I had. Let's see. 7, 8, 9, 10. Yeah. So these start at number 7. So they're giving me f of x equals x minus 6. All right. So if you wanted to graph this, all this is a basically, if you was to look at the graph, so there's your x and y. This is just a line going uphill left to right when you graph it, but guess what? It passes the horizontal line test. So it's going to be 1-to-1. So y'all don't even waste time having to graph them. Just put yes for A. So we're going to find the inverse out of this. So look here. The first thing it says, replace the f of x with a y. So you're going to come in and go y equals x minus 6. All right, so we did that. Y is now here instead of f of x. Next thing we said, hey, we're going to switch to x and y variables. All right, let's switch to x and y variables. So let's see, we're going to switch x and y so that this becomes x equals y minus 6. So y'all guess what? At this point, you're solving for y. And you got one move to get this y all by itself. You got to move this -6. And you're going to do that by adding 6 to both sides. Well, these are not like terms, so that's just going to stay at x plus 6. Over here, the 6's cancel. All that's left is my y. So we solved for the y variable. Now, the last step, replace this y with our f inverse notation. So now I'm just going to put the f inverse first. So this f inverse of x equals x plus 6. Now, all you put in the answer blank is the x plus 6, okay? So y'all, my last step I did here was what? Replace y with my f -1 of x. And y'all, that's the trick. We now have the inverse function. Now look at this. What do we notice about this inverse? The actual function was -6. Look here, the inverse was +6.
Positive.
Yeah, you're going to see all kinds of opposite type counter moves on these, okay? So let's do another one with a line. This one says f of x, y'all, is going to equal 7x minus 9. I'm going to do everything I did to this side. I'm going to replace that f of x and make that a y equals 7x minus 9. Next, I'm going to switch that x and y around. So this will give us x equals 7y minus 9. And y'all notice, all I'm doing is following them 4 steps. Now that we've got them switched, we need to solve for this y. So a little more work than I had over here. But first, I would move that -9.
9 over.
Yeah, so let's add the 9. So I get what? A x plus 9 equals to 7y. All right, so now you want that to be 1y. So I'm going to divide both sides by 7. So over here, remember, the whole thing, the x plus 9 are both dividing by that 7. All right, y'all, so we cannot do anything to simplify the left side. So the left side will stay x plus 9 over 7. But over here, the 7's cancel, making that a 1y. All right, y'all, we cannot simplify this. So we're going to have f -1 of x equals x plus 9 divided by 7. Now look, this 9 was added, this 9 was subtracted. This 7 was being multiplied, this 7 is being divided. So a lot of opposite moves you'll notice with these answers, okay? All right, y'all, so questions on these two. And like I said, they're not too bad. You just got to go in your steps, okay?
Hold on, don't flip it yet, please. 1 second.
Some of the better math we do in here, huh? I think they're better than doing that stuff y'all did the other day, the composition stuff. where we was having to put stuff in and foiled and all that fun stuff. All right, so what do we see? Number 9, y'all. Now this one is a little trickier. I got f of x equals 8 over x plus 1. So part A, yes, this is 1-to-1. So we will find the inverse. So change the f of x to a y. We'll have y equals 8 over x plus 1. So y'all, what's our next step?
We are going to
Oh,
I
I
was,
can't-
I was gonna say switch the X and Y variables.
oh, that sounds good to me. So that'll give me 8 over y plus 1. So good job. So here's the thing on this one. Y'all remember the first 2 problems in support were cross multiplying? So I'm going to make this look like a fraction equal to a fraction by putting a 1 under this left side.
Okay.
Because remember, to cancel out these fractions now, I can cross multiply this. So
Mhm.
y'all, I'm going to take this x times the y plus 1. That's going to equal this 1 times the 8, which is just what, an 8. So here's the thing. There's 2 ways we can solve this. And I'll show you both ways you can do this. Okay. One way is we can distribute that x to get rid of these parentheses.
Mhm.
So I can do x times y and get an xy plus x times 1 is an x, all equal to my 8.
8.
Now, we're solving for the y, so this little x is being added. We're going to come in and subtract it from both sides. So look what happens. I get my xy here. All these x's cancel on the left side. But over here, we can't do nothing to that. They're not like terms. So we're just going to keep that at 8 minus x.
Mhm.
All right. You got an x times a y here. You want this to be a y by itself. So since the x is being multiplied here, we got to divide both sides by that x. Because see, these x's will cancel just like a number and give me 1y. But that means over here, 8 minus x has to be divided by my x. So y'all right here, that cancels, giving me a 1y. Now here's the biggest mistake I get here. These x's cannot be canceled out because there's not an x with that 8. If I had, say, 8x minus x over x, yeah, then you could start canceling x's out. But you cannot cancel these x's out because it's not in all 3 terms. So guess what? You cannot do nothing to that. And guess what? Final step, make this y. F inverse of x equals 8 minus x over x. This is one way it will take that answer. Now, y'all, let me show you the other way. Now, the other way is the way I usually like to do them. So I'm going to start at this point. Now, I'm going to do this without distributing that x. My first move, instead of multiplying that x through, I'm going to divide both sides by the x. Because look, if I divide by x, them x's are going to cancel, and all that's going to be left is the y plus 1. And then I'll go over here and divide that 8 by x. So look, the x's cancel, and I'm left with the y plus 1 equals my 8 over x. And look here, my last step is to subtract 1 from both sides. So you get your y. Can't do nothing here, so that's just going to be an 8 over x minus 1. This answer is the same as this answer if you was to write this answer as 2 fractions versus 1. Math Lab will take either way, okay? So
Okay.
f negative 1 of x can equal 8 over x minus 1. Either way, okay? And I wanted y'all to see that you could distribute the x here, or you could divide the x out and not even worry about distributing it, okay? All right, y'all. Next was number 10. So this one I got f of x equals x to the third minus 4. Now, these x to the cubes are those little graphs that sort of did that little squiggly line, but they are 1 to 1, okay? So that means we will find an inverse to this. All right, y'all, first step, change that f of x into a y. All right, y'all, I'm going to switch both sides now so that I get a x equals a y to the third minus 4. So y'all, here's the thing here. Since I got a variable with an exponent, what I need to do in this, in order to solve this for the y, I need to get this y to the third by itself. So get the y to the third by itself on the right side. Well, to get this y to the third by itself, this 4 is being subtracted. We're going to come in and add 4 to both sides. So this gives me x plus 4. Can't do nothing with that. But over here, the 4's cancel, and all that's left is my y to the third. So y'all, here's the question. How can I turn a y to the third into a y?
Can you square root it?
Oh, you know what? You are perfectly on the right path, but instead of a square root,
A cube root.
a cube root. There you go.
Oh, well, that's what I meant, but
So while go, exponents cancel the roots. Well, roots cancel the exponents. So if we have anything like a to the n, which is my y to the third, technically, if I do a nth root of it, if the root matches the exponent, they're going to cancel, just leaving us our a. So good job. We're going to do cube roots to both sides. So cube root of x plus 4 will equal a cube root of y to the third. Well, y'all, you can't do nothing to that. You can't take the cube root of something that you don't know what the x's are. So that side's going to stay the same. But look here, that cube root cancels with that exponent, leaving me a y. And my last step, remember, f negative 1 of x replace y with f negative 1 of x. And in the answer blank, I would put what? A cube root x plus 4. Now, when you put this answer in, when you click in the answer blank, it'll pop open that little roll of stuff you can choose out of. On this one, you choose the little radical thing, and it'll have like a little blue box there. That way you can put in that 3 for that cube root, okay? All righty, y'all. Question on that.
No questions.
Y'all, they're not too bad. Here we go. F of x equals. Now here's one. Oh, that's right, Jerry. That'll work. I got that video for you. This one has 2x squared plus 3. But y'all, then it's got a comma and it says x greater than or equal to 0. So let me show you what they're saying. If you remember a while ago when I was talking about the one-to-one stuff, if you were to graph this one, it would look like a parabola going uphill like this on both sides. This is not one-to-one, but look what they're saying. They're saying we're only looking at the graph for any x's that are greater than or equal to 0. So they're getting rid of all this side of the graph. They're only looking at the x's from 0 to infinity, which means that this one little part of the graph, if I restrict it, it is one-to-one. So that's how they can make a function that's not one-to-one, one-to-one if they want to use this part, okay? So once again, I'd have put yes that it's one-to-one. Now, the function is the 2x squared plus 3. This has no bearing on the problem other than they restricted the x's, okay? So replace the f of x. Now watch this. We got a math lab on this one, gave us this much of the answer. All we got to figure out on this answer, what goes on the top of this fraction. They're giving me the square root in the answer already. They're giving me the 2 on the bottom already. They gave you this much of the answer. All we got to do, like I said, is fill in what's going here. So y'all, when we get done, we better look something like that, okay? So the first step, replace the f of x with a y. All right, y'all, next step.
We flip it.
Okay, so that'll be x equals 2y squared plus 3. So now y'all's goal is to get this y squared by itself like we did the y cubed up here. So your first move, you got to get rid of this 3. So it's being added. You're going to come in and subtract. And y'all really, whoops, that's all equations are is, focus. That's all equations are. When you solve equations, you're just doing counter moves to get stuff stripped down. So this side, you can't do nothing. That's x minus 3. This side is just a 2y squared. Now remember, I want this y squared to be 1y squared, not 2y squared. So I'm going to come in on both sides and divide by 2. So y'all look, on the right side, the 2 divided by 2 makes that a 1y squared. So that's going to be a y squared. And we can't do nothing to this at the moment. But it's starting to look like this answer, right? And y'all, I bet that last answer, the last thing we do to this will make it look pretty good. How can I turn this y squared into a y?
Now you square root it.
Now we're going to square root it. There you go. And we can't do nothing to that, so that's going to stay a square root of x minus 3 over 2. But now this radical cancels with that exponent, leaving me my y. So y'all, the only thing I got to put in this answer in Math Lab is the top of that fraction, and we're putting
X minus 3.
x minus 3. Perfect. So that was nice of them to give us, I guess, that much of that one, right? All right, y'all. So I got one more for you. So this one will be like your number 12. F of x is going to equal a square root x plus 4. Now, if you use to graph this square root, it just sort of looks like a slow uphill graph, but it is 1-to-1. So replace the f of x with a y. Which the x and the y. Now, y'all remember one thing, this number, this 4 is under the radical, so we can't subtract 4 from both sides or anything like that until we do something first. What is our first move we got to do? We want to get rid of this radical.
You squared?
I'm going to square it perfect because that's what we did a while ago. Remember on our support when we had radicals, we raised both sides to the exponent that matches the radical. So we're going to square both sides. So that'll give me an x squared equals my square root of y plus 4 squared. But we couldn't do nothing with the x squared, so bring that down. But here, remember, the radical cancels the exponent, leaving a y plus 4. And y'all, one more move and I can be done. I want that y by itself. So to move that plus 4, we're going to subtract 4.
Subtract from both sides.
Mm-hmm. So nothing we can do here, so that's just going to be x squared minus 4. But y'all over here, the 4's cancel, leaving my y. So notice, if you start with radicals, you're going to end with x's raised to whatever these exponents are that match those indexes. When we started with exponents, we ended up with square roots, cube roots that match those exponents, okay? All right, y'all. So f inverse of x equals x squared minus 4. So counter moves, square roots squared, adding, subtracting. Okay, watch for all them little counter moves. All right, y'all. So here's the thing. Next week will be the last week of material for my first test, okay? So next week we'll do our 3-5, 3-6, 3-7. And then the week after, that Monday or that Tuesday, I mean, we're reviewing for the first test during that class, okay?
Okay.
So we'll do a review just like the test, just like your review quiz will be. That way you get ready for it before the test. Now, next week is a good week to have a calculator. I'm going to show you things on your calculator to do these problems with. Now, listen, if you don't have a TI-83 or TI-84, get this little, I got this little Calculate 84 app on my phone. And the Calculate 84 app is the same as the calculator I'm going to be showing you in class. So if you don't have a physical calculator, get one of these calculators out of your app store, okay? Because like I said, it does everything. I can graph on them. I can do everything I can on my TI-84, okay?
Yeah, I got that one.
Yeah, and it works the same as what we're going to be doing, so yeah. Alrighty, y'all, so let me stop this share. And I'm gonna get my video stopped.